You ever look up at the night sky and just get lost in all those different points of light? You've got bright ones, dim ones, some that are kind of reddish, others that are blazing blue. But what if they weren't? What if every single star out there was identical? We're going to run a little thought experiment here, imagining a cosmos that's been stripped of its most essential ingredient, diversity, just to see how unbelievably important that variety really is. All right, let's dive right in with the big question. What if the universe just gave up on variety? What if it decided to make every single star a perfect carbon copy of our own sun? Not a bit bigger, not a bit smaller, not hotter, not cooler, just trillions upon trillions of identical suns. I mean, what would that universe even look like? So, to really get a handle on this, just look at the difference. Our universe is a place of wild extremes. We've got these tiny little stars, barely 8% the mass of our sun. And then we have these absolute monsters, over 150 times more massive. And their lifespans, they range from just a few million years for the giants to trillions of years for the little guys. Our made-up universe? Nope. It's got one option, one size fits all. The result in our universe is this incredible richness and complexity. The result in the other? Well, let's just say it's stagnation. And we're about to find out why. And the first problem, the most devastating one, is all about chemistry. You see, in a universe of identical suns, the cosmos would be missing its master chefs, its cosmic alchemists. It all comes down to this one crucial process, nucleosynthesis. This is literally how the universe builds anything more complicated than the hydrogen and helium it started with. You can think of stars as these giant cosmic forges, and nucleosynthesis is the process of smashing simple atoms together to make more complex, more interesting ones. But here's the thing. Not all forges are created equal. Stars like our sun, they're pretty good at one thing, fusing hydrogen into helium. But that's kind of it. It's the really rare, supermassive stars that have the insane pressures and temperatures needed to forge all the heavier elements that make our world, well, our world. And here's what we'd lose. Take a look. Without those massive stars, there's no carbon, the basis of life. There's no oxygen to breathe, no iron for the core of our planet. And forget about the fancy stuff like gold or uranium. All the fundamental building blocks for rocky planets, for complex chemistry, for you and me, they just would never get made. They're all the product of stars that simply wouldn't exist in this uniform cosmos. This basically creates a cosmic dead end. The universe would start out just like ours did, a whole lot of hydrogen and helium. The first sun-like stars would light up and fuse a little bit of that into carbon. And then, nothing. The whole process would just hit a brick wall. Without the violent, high-energy deaths of massive stars to create and spread heavier elements, the universe's chemical evolution is just frozen, stuck in its infancy forever. So, a universe with only sun-like stars is a chemical wasteland. Got it. But what if we picked a different star to be our standard model? Let's play with the extremes. A universe filled with only the tiniest stars, or one filled with only the biggest. What we get are two equally impossible realities. On one hand, a universe of tiny red dwarfs would be incredibly old, but also cold, dim, and totally stagnant. And on the other hand, a universe of massive blue giants would be this spectacular, violent light show that burns itself out in a cosmological blink of an eye. I mean, just picture a red dwarf cosmos. It would go on for trillions of years, just a sea of faint reddish dots. But because these stars just sip their fuel and never go supernova, you'd never see a brilliant nebula. No stellar explosions would ever enrich the cosmos with new elements. It would just be a quiet, cold, and unchanging eternity. Kind of boring, right? Now let's flip it. The blue giant universe. Wow. It would be a place of absolutely breathtaking violence and beauty. Galaxies would just blaze with this unimaginable light. But it would be over almost as soon as it began. These stars only live for a few million years before they explode. There's just not enough time for planets to form, let alone for life to evolve, or for any kind of lasting stability to ever take hold. It's all flash, no substance. You know, this lack of variety, it does more than just mess up chemistry or cosmic lifespans. It fundamentally breaks the entire ecosystem that lets a galaxy actually function and evolve over billions of years. See, in our universe, star formation follows a very specific recipe. For every one massive, short-lived star that's born, nature cooks up hundreds of smaller, stable, long-lived stars. The giants are the element factories, and the little guys provide the long-term, stable homes. It's a beautiful balance. A uniform universe throws that entire balance out the window. And without it, galaxies can't really evolve. They just become these inert, sterile blobs of matter. And just think about the view from a planet in a universe like this. It would be haunting. You'd look up and see no constellations, no difference in color or brightness, just a perfect mathematical grid of identical lights. It's this vision of absolute order, but it's hiding a complete lack of potential, a sky that tells no stories. And this cascade of sameness, it doesn't just stop with the stars. Oh no, it trickles all the way down to any planets that might manage to form around them. In our varied universe, you get this huge range of possibilities. For a planet to be warm enough for liquid water around a dim little red dwarf, it has to get in real close. We're talking less than a tenth of the distance between Earth and the Sun. But around a scorching hot blue giant, that same Goldilocks zone is pushed way, way out, more than 10 times farther than Earth's orbit. This variety in location creates this huge portfolio of different kinds of worlds. But in a universe of identical suns, every single habitable zone would be in the exact same spot. Every planetary system would have to follow the exact same blueprint. All those countless unique ways a world could form and evolve, gone, just erased from existence. So all of this, it brings us to a final and I think really profound idea about the nature of our cosmos and what actually makes it tick. Without that rich mix of different stars, the story of the universe just grinds to a halt. You see, cosmic evolution is this amazing cycle of creation, destruction, and renewal. The hot mass of stars create new elements and then die spectacularly. The cooler, smaller stars provide stable, long-term homes where those elements can become planets and, eventually, life. One without the other is like a story with no plot. And this, right here, is the ultimate takeaway. The apparent messiness of our universe, that wild spectrum of star sizes and temperatures and lifespans, that isn't a bug. It's the most important feature. It's not noise in the system, it is the system. It's the very engine that drives all of creation and complexity. That uniform cosmos we imagined would be perfectly orderly, sure. It would be mathematically elegant, but it would be completely sterile. It would be like a single, unchanging note held for all eternity. A frozen harmony, yeah, but with no melody, no rhythm, no music. It would be a cosmos that could never surprise itself because nothing new could ever possibly happen. It really makes you wonder, doesn't it? Our very existence seems to hinge on this messy, beautiful, chaotic variety. And that forces us to ask a pretty deep question. What other things that we see as cosmic flaws or imperfections are secretly the most fundamental keys unlocking the entire story of the universe and our own place within it?